And welcome to this video on binomial expansion. So binomial expansion, we're talking about something like a plus b to the power n. Now this is not the same as x to the n plus y to the n. So take that out of your mind straight away. So totally not that. A plus b to the n is, if it was n was 2, that's a plus b multiplied by a plus b, and that equals a plus b to the power 2. So let's have a look. A plus b to the 0, that equals 1. A plus b to the power 1, that equals a plus b. And we think of there being a 1 in front of the a, but we miss it out. Okay, wherever there's a 1 we miss it out. What about a plus b squared? So a plus b to the power 2. So as we said in the above example, that's a plus b times a plus b, and that's like a standard result. So that's a squared plus 2ab plus b squared. And again, we take it that there's a 1 before the a and a 1 before the b, but we don't write that in. Now what about getting to higher powers? So a plus b cubed. So that's nothing but a plus b, and we multiply that by a plus b squared. So as we did before, so that's a plus b, and the result for a plus b squared was over here, so that's a squared plus 2ab plus b squared. And when we multiply that out, we get, if we multiply by the a, we get, so we're going to multiply this out, we get a cubed plus 2a squared b plus a b squared. So that's multiplying out the a like this. And then if we multiply out the b, we get a squared b plus 2ab squared plus b cubed. And then when we add these together, we get the result for a plus b cubed equals, so we add this, that's a cubed plus 3a squared b plus 3ab squared plus b cubed. So as you can see, this is getting quite complicated, and if we do quickly a plus b to the power 4, we get a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power 4. So when we look at this, we see there's a little pattern going on, and if we have a closer look at the pattern, we've got, first of all, we've got the a here as a 4, then we've got the a as a 3, then we've got the a as a 2, then we've got just the a, and then we've got no a. And in the b's we've got the no b with the a to the power 4, we've got 1b here, we've got b squared here, we've got b cubed here, and we've got b to the power 4 there. So another thing that's going on is there's a coefficient. So if we let c equals the coefficient, so there's some coefficient which is 1 before there, before the a to the power 4. There's some coefficient there which is before the second term, and there's some coefficient there, some coefficient there, and some coefficient there. So the pattern is there's a coefficient a to the 4 plus a coefficient a 4 minus 1 and then b 1 plus a coefficient a power 2 which is 3 minus 1 b squared. So in each step a is going up, is going down in a power, and b is going up. If we have a look at Pascal's triangle, so it goes something like this: 1 1, put a 1 there, then a 2 and a 1, then a 1, a 3 and a 1, a 1, a 4, a 6, a 4 and a 1, and then a 1, a 5, 10, 10, 5 and a 1. So that's Pascal's triangle, and along the side we put which step it belongs to. So this would be 0, 1, 2, 3, 4, 5. So if we have f of x is x plus y to the power 4, and we want to expand this, we can get the coefficients that we were discussing earlier from Pascal's triangle. So what we do is we look at the power 4, and then we go down the triangle 0, 1, 2, 3, 4, and this line represents the coefficients of that expansion. Also, if you look at the power, this should be the second, the coefficient in the expansion. So let's do a quick expansion of x plus y to the power 4. Let's write down our coefficients first. So this would be 1, 4, 6, 4, 1. So that's for the power 4, and 4 is our second coefficient in the expansion. Then we get our a, which is here, and our b, which is there, as we were discussing before. So our a is going to go from x to the power 4 and reduce, so x to the power 3, x to the power 2, x to the power 1, and finally x to the power 0. And then we're going to multiply this by b, and that is going to go down in powers. So this is going to be y0, y1, y2, y3, y4. And if we write it this way, then we can quickly get the expansion. So now we just multiply this out. So this is just x to the 4, power 4. This is 4x to the power 3 y, 6x squared y squared, 4x to the power 3, and this is y to the 4. And so our expansion, x plus y to the power 4, then becomes, we just follow this down, x to the power 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power 4. When we're dealing with a minus in the binomial, we have to be very careful. So if we have x minus y to the power n, our y is minus y. Okay, and we have to carry that minus through in our calculations. So for example, if we had 4 minus 3y to the power 3, and we want to expand that, we do our coefficients from our Pascal's triangle. So power 3, we go to the third row with the 3 in the second position as the second coefficient. So we get 1, 3, 3, 1. So we multiply this by our a, which are going to go down in power, so it will be 4 to the power 3, 4 to the power 2, 4 to the power 1, and 4 to the power 0. And then we multiply this by our minus y, so this would be minus 3y, 0, minus 3y, 1, minus 3y, 2, and minus 3y to the power 3. And then this would give us 4 to the power 3, 3 times 4 squared, so minus 3y, 3 times 4 times minus 3y squared, and then finally minus 3y to the power 3. And then we work that out. That's 4 cubed is 64 plus 58 minus 3y plus 12 times 9 y squared plus 27 y cubed. And when we tidy that up, that's 64 minus 144 y plus 108 y squared minus, sorry, because this was to the power 3, there should be a minus. So this is minus 27 y cubed. Okay, another way of doing a binomial expansion when we can't use Pascal's triangle, or we don't want to use Pascal's triangle, is to use the NCR to find the coefficient. So NCR is usually written like CNR, and this essentially stands for n factorial divided by r factorial n minus r factorial. So what does this mean? So n factorial is n minus 1, n minus 2, and so on. So if we have 4 factorial, this means it's 4 times 3 times 2 times 1. And similarly, 5 factorial is 5 times 4 times 3 times 1. So 4 factorial is 24. If we look at 5 factorial, in there we have a 4 factorial. So basically 5 factorial is 4 factorial times 5, which is 120. So when we write out this NCR as C42, for example, this means 2 choose 4. And what do we mean by that? Well, let's have a look. If we have this, using our formula, this becomes 4 factorial over 2 factorial, and then 4 minus 2 factorial, and this equals 6. So this means there are 6 different ways of choosing 2 things from a collection of 4. Sometimes in some textbooks they write this as 4, 2. Now this expansion is used, so we would have x plus y to the power n. So our first term would be x to the n. Our second term would be c n1 x n minus 1 y, plus our next term would be c n2, x would be to the power n minus 2, and y to the power 2, and so on. So what we notice in this expansion is that the x is going down by 1 in every term, and y is going up by 1 in every term, and our coefficient value, which we got from Pascal's triangle, we can get from our NCR value, which is going up. So it's going the NC1, NC2, NC3 up to n value, which would be just 1. The other thing to bear in mind is what each y value is the bottom value in the NCR, so it's the R value. Let's have a look at an example. So if we have 2a minus b, let's have a look here, 2a minus b to the power 3. This would be our x is 2a, so 2a to the power 3 would be our first term, then c31, 2a, 3 minus 1 is 2, and then minus b, plus our NCR term becomes 3, 2, 2a, which is our x term, goes down by a power of 1, which would become just 1, and then our minus b increases to 2, and then our next term would just be b, or minus b to the power 3. So this then becomes 8a cubed. Because of the minus b, it's a minus. See, this NCR value is 6 when we work it out, so this becomes 12a squared b, plus this NCR value when we work it out is 3, so this becomes 3 times 2 is 6, a minus b squared is b squared, and then minus, because b cubed leaves us with a minus, b cubed. The binomial theorem can be used for very large powers, and also for fractional powers. Let's have a look at the binomial theorem then. The binomial theorem has to be in this form, so your binomial has to be in the form of 1 plus x to the power n, and then we can expand, and it goes 1 plus n x, so this would be our x term, plus n multiplied by n minus 1 all over 2 factorial x, which is our x there, squared, plus n minus 1 n minus 2 x, which is our x in the binomial, cubed, all over 3 factorial, and so on. And like I said, this can be used for very large powers and also for fractional powers. So for example, if we had the square root of 1 plus 2x, so this is the same as 1 plus 2x to the power half. So our n equals a half and our x equals 2x. So let's apply this rule. Usually when we're doing this we only go to 3 terms, and this gives us a estimation of the expansion. So usually we only go to 3 terms to give us an estimation of the expansion. So in this case it would be 1 plus 2x to the half. This is equal to 1 plus the half, which is n, times x, which is 2x, plus a half, and then we multiply by n minus 1, so half minus 1 is minus a half. Okay, and then we multiply by our 2x squared, which is our x squared, so that would be 2x squared, and then our 2 factorial becomes a half. Okay, and then we continue. So this then gives us 1 plus x plus minus 1 over 8 4x squared, and then our third term would be 24x cubed over 48 plus. But like I said, we just try and stick to about 3 terms. It's very important that when we're using the binomial theorem that the binomial looks like this, in this form. So let's have a look. If we had 1 plus x minus x squared to the power 7. So what we'd have to do is make it look like a binomial, so make into a binomial. And this would then be 1 plus, then in brackets, x minus x squared, so that would be our binomial, and that will be to the power 7. So this would then equal 1 plus and we're going to use our coefficients, the NCR ones, so this would be 1, 7, x minus x squared plus c7, 2, x minus x squared whole squared plus c7, 3, x minus x to power 2 cubed. The binomial theorem can also be used where we have a negative fractional power, but remember it has to be in the form 1 plus x to the power n to be used. The binomial has to be in this form so that we can apply the binomial theorem. So for example, if we had 4 minus 3x to the minus a half, we convert to form a plus x to the power n, and the formula that we've used is a plus x equals a to the power n, 1 plus x over a whole to the power n. So let's have an example. So this 4 minus 3x to the power minus a half then becomes 4 to the minus a half, which is a to the n, 1 plus minus 3x over 4, and all that to the power minus a half. And if we work that out, that's 4 to the minus half is a half, 1 plus minus 3x over 4 to the minus a half. So the first three terms if we use the binomial theorem would be the first three terms if we use the binomial theorem would be a half, which is this half coming down, 1 plus minus a half minus 3x over 4, and that would be our first term, plus minus a half minus 3 over 2, which is n minus 1. Then we have minus 3x over 4 squared, and then our 2 factorial, which would be a half. And the third term in a binomial expansion. So how do we do this? Well, first of all, we have to remember what we do when we do the binomial expansion. So if we have x plus y to the n and we expand, the first term is x to the power n, the second term is the CNR, which is cn to the 1, then x, n minus 1, y, and so on. So this is the second term, and this is the first term. Now if we notice in the second term, the CNR, the coefficient, is actually, the r value is 1 less than the term value. So if we're looking for the second term, this would be 1, cn to the 1. If we're looking for the third term, it would be cn2. So if we write that out, we get, if the term is r, then we get c to the r minus 1 n, and x would be n minus r plus 1, and then the y will be the same as this, which is r minus 1. So this x we can sometimes think of as if we get n minus r minus 1. So we can think of this as if we had, for example, let's do an example. 2x plus 3 to the power 4. What's the third term in the expansion? So let's write that out. So this would be c n, r minus 1 would be r minus 1, so that would be the third term minus 1, that would be 2. Then we'd have the x, so in this case that's 2x. And then we'd have n minus r minus 1, so that's 4 minus 2. So we can write that out here, 4 minus 2. And then the y, which is the 3, which would be to the power 2. So this then becomes, the n is 4 here, sorry. So this then becomes 6. 2 to the power 2 is 4. Y is 3. 3 to the power 2 is 9. And from here we have x squared. So this is then 216 x squared. Here we're asked to find the fifth term in the expansion of 1 minus 2p to the power 8. So our r, which is our term, is 5, and r minus 1 is 4. So this then becomes c to the power 8, that's n. Our r is 5 minus 1, which is 4. Our x is 1, and that is 8 minus 4, which is 4. And our minus 2p is to the power 4. And when we work that out, this becomes minus 2 to the power 4, p to the power 4, and multiplied by c8, 4. And this equals 16 p to the power 4. Sometimes we can be asked to find a coefficient. We can only do this if there's an x in both terms. So to find a specific coefficient, for example the coefficient that's attached to x to the power 9, and we're expanding 3x plus 2 over x to the power 15. So we know that our CNR A, and that will be to the n minus r, and then b will be in the bottom to b to the power r. This would equal c, and then we know our n is 15. We don't know our r. Our a value is 3x, and that would be to the n minus r, so that's 15 minus r. And our y value, or our b value, is 2 over x, or 2x to the minus 1, and that would be to the r. Now if you call that our equation 1, now we're only interested in the x terms that are going to make x9, x to the power 9, so we're interested in this, and we're interested in this. So this then becomes x to the 15 minus r multiplied by x to the minus r equals x to the power 9. So x 15 minus 2r, when we use our exponent rules, equals x to the power 9. So 15 minus 2r equals 9, and our r then equals 3. So that is our answer for r. Now what we need to do is plug r back into our equation. So replace r into our equation 1, and we get c 15 3x, and our 15 minus r would be 12, and our 2x to the minus 1 to the power 3. And that would give us our coefficient. Another type of question you can be asked in binomial expansion is to find the constant term. Now the constant term is where there is no x, so we have x to the power 0, and we can only do this if there's an x in both terms. That's in A and B. So let's find this for 2x squared plus 4 over x all to the power 12. So we're going to find this for this expansion. And now let's first of all do our C and R. So it's C and R for any term is C and R A, n minus r, and then b to the r. So in this is our A and this is our B. So let's put this into the formula. So this would be a C. Our n is 12 and our r we want to find. Then we have our 2x squared as A, and this is to the 12 minus r, and then we multiply this by our 4 over x, which is 4x to the minus 1, and that's to the power r, and we'll call this equation 1. Now what we do is we're only interested in the x's, so we're only interested in this part of this equation. So if we write that out, we get x squared to the 12 minus r multiplied by x to the minus 1 r equals x to the 0. So we have x 24 minus 2r multiplied by x minus r equals x 0. When we combine here, multiply them together using our law of exponents, we get x 24 minus 3r equals x 0. So 24 equals 3r, and our r equals 8. Now what we have to do is put this back into our equation 1. So now sub into 1. So we get C 12 8 as our C and R value, 2x squared to the power 4, 4x to the minus 1 to the power 8, and that will be our constant term. Okay, we want to find the x to the power 7 term in the expansion of 1 minus 2x plus x to the power 3 all to the power 6. Now we notice that this doesn't look like a binomial, so we have to convert. So when we convert this into a binomial, we get 1 plus x cubed minus 2x, and all this is to the power 6. So this is our 1, or our a plus b. We notice that there isn't an x in the a, so we can't use the previous method that we used. So we have to do some algebraic sort of method. So we know that in the expansion we get 1 plus c61 x 3 minus 2x plus c62 as our NCR, x to the power 3 minus 2x squared plus c63 x to the power 3 minus 2x all cubed, and so on. Now let's look at this value, this term here, and see if there is x to the power 7 in that term. So if we have c 63 x to the 3 minus 2x to the power 3, this then becomes 20 c3 to the 1 x to the power 3 squared, and then minus 2x to the power 1. So we can see that this, when we multiply out, will give us an x to the power 7. If we have a look here, this is x to the power 3 to minus 2x to the power 1 will give us an x7. So this is one of the terms that we need, and this is, when we work it out, is minus 120x to the power 7. Okay, so let's have a look, are there any other terms? So what's the next term along that might give us an x to the power 7? So if we have c6 to the 4 x to the power 3 minus 2x to the 4, will that give us anything? Let's have a look. So this will, when we work out the CNR value, that's 15, and inside the brackets we get 4c1 x to the power 3, 3 to the 3 power 3, and then minus 2x to the 1. So we can see here straight away that this is going to give us an x to the power 9 so this isn't going to work. Let's have a look at further along. So if we have the next term, which is the x5, x to the power 3 minus 2x to the power 5. This is going to give us 6 on the outside as our CNR, then inside the brackets we're going to have 5, 4, x to the power 3 to the power 1, and minus 2x to the power 4. So we can see this is x to the power 3 and x to the power 4 added together. That will give us an x to the power 7. So this equals 480 x to the power 7. So when we add these two together, so 480 x to the power 7 plus minus 120 x to the power 7, we get 360 x to the power 7. And we have to find a and n. So let's have a look at the binomial theorem. It says that 1 plus ax to the n equals 1 plus n, and then this would be ax plus n minus 1 over 2 factorial a squared x squared plus, and then carry on. So this then is the same as 1 plus a nx plus n minus 1 over 2, because 2 factorial is 2, and then a squared x squared plus, and then it continues. So if we compare coefficients, so for our x we had 12, so we have an equals, minus 12, and then for our x squared we had 63. So all this n minus 1 over 2 a squared equals 63. So if we label this equation 1 and label this equation 2, we can see that we can get a to equal something here. So we have a equals minus 12 over n, and if we sub this now into 2, we get n minus 1 over 2, and our a squared then becomes 144 over n squared, which is n times n, and this then equals 63. Here we can do some cancelling, so our 2 cancels with 144, this n cancels with this n, so we're left with, this becomes 72, so we're left with n minus 1 multiplied by 72 equals 63n. So 72n minus 72 equals 63n. 9n equals 72, and our n equals 8. So we worked out our n, And now what we do is, to get our a value, we plug this 8 into our equation 1, and we get a8 equals minus 12, so therefore a equals minus 12 over 8 equals minus 3 over 2. Sometimes in a question we can be asked to expand and then use that expansion, which are essentially powers of x, for differentiation or for integration, and usually we're asked to expand a similar kind of binomial and then manipulate it by division or addition or subtraction, and then integrate or differentiate using our power rules. So for example, if we have expansion of 2 plus y cubed, we get 1a cubed plus 3a squared y plus 3a to the power 1 y squared plus y cubed. When we substitute in our a, which is 2, we get 8 plus 12y plus 6y squared plus y cubed. So now we're asked to find the integral of 2 plus x squared to the power 3 plus 2 minus x squared to the power 3 dx. So how do we do that? Well, first of all, we work out our expansion of 2 plus x squared to the power 3, and this is quite easy because we've already done something similar here. So all we have to do is, wherever there's a y, substitute that for an x squared. So we get 8 plus 12x squared plus 6x squared to the power 2 plus x squared to the power 3, and this equals 8 plus 12x squared plus 6x to the power 4 plus x to the power 6, using our rules of indices. So that's the first one done. Then for our 2 minus x squared to the power 3, we get 8 plus 12 minus x squared to the power 2 plus 6 minus x squared to the power 2 plus minus x squared to the power 3. And when we work that out, that gives us 8 minus 12x squared minus 6x to the power 4 minus x to the power 6. Now we have to add this, which we'll call 1, and this together as per our integration, and we get 1 plus 2. So the plus 12 minus 12 cancels, the plus 6 power 4 minus 6 power 4 cancels, and the plus 6 to the power 6 plus x to the power 6 and minus x to the power 6 cancels. So all we're left with the 8, and 8 plus 8 is 16. So this integral is simply the integral of 16 dx, which is 16x. In the using the binomial theorem, we have to show that the square root of 5 is 1145 divided by 512. So how do we do that? Well, first of all, we have to say that the square root of 5 is actually the square root of 4 plus 1. Okay? Square root of 5 equals the square root of 4, 1 plus a quarter. And then eventually this equals the square root of 4 is 2, and 1 plus a quarter, the square root of that we write a half. So we have to work out, or we have to use the binomial theorem here on this binomial, and with the 2 on the outside we multiply through by the 2. So here we have n equals a half and our x equals a quarter. Okay, so now let's use our binomial theorem. So we get 2 on the outside, so 1 plus our nx, which is our half, times our quarter, and we add this to our half, plus n minus 1, which is a minus a half, plus 2 multiplied by 2 factorial, which is a half, and then by the x, which is a quarter squared. Similarly, the next term, that becomes a half multiplied by minus a half, multiplied by n minus 2, which is minus 3 over 2, multiplied by 1 over 6, multiplied by a quarter, which is 4 factorial cubed. This is to the first 3 terms, which is usually all we require to get an approximate answer. So this then, when we work it out, becomes 2, 1 plus 1/8 plus minus 1/8, a quarter squared, plus 1 over 16 and a quarter cubed. When we work this out, this becomes 2, so we multiply through by 2 as well. So 2 plus 1 over quarter minus 1 over 64 plus 1 over 512. And this equals 1145 over 512, which is approximately 2.26.